Okay, folks, I think what I'll do tonight is just for a little short video clip, kind of show you how I get started up imaging with the telescope. So I've already gone outside and turned on the telescope and got all the power running. Everything's checked outside. So then I come back in here and I'm going to connect the telescope to this program right here. It's called the SkyX Imaging Edition. So this is where I'm going to run the telescope from. So we're going to go here to telescope first, and we're going to connect it. So it says it's a software BIS Paramount X. I'm going to connect the telescope, and it's connected. And it's asking me if I want to send it home, and I don't yet. What the home does is it points to the southwest at a predetermined location, and then once it's home, it knows exactly where it's sitting on Earth. So then I can move it around to objects, and it knows where those objects are. So we're going to let it sit there for a minute while I go ahead and I'm going to connect the camera. So I'm going to camera setup. Settings. I'm going to pick the ASI 2600 mono. That is an APS-C sensor mono. Um, and I'll make sure that's right. And then hit OK, and then I'm going to connect it. It's taking a minute because it's also connecting the filter wheel that it's attached to. So it's ready, and now the filter wheel is ready too. This has got my filters in it: luminous, red, green, blue, HA, sulfur, and oxygen. That's what we'll be using tonight. So now I'm going to go to my guider, which is the smallest telescope on the mount that keeps it tracking like it's supposed to, and I need to connect it. And I need the settings. I need to make sure it's the 071 color camera. Hit OK, and I'm going to connect. Okay, and then we're going to connect the focuser. And I got two focusers, so I got to go check the focuser that I want, and I want the focuser. It's on the 81 millimeter telescope, so that's the one I want. Hit OK, hit OK, hit OK, hit OK, and connect, and it's connected. All right, so now everything on the telescope is connected. So I'm going to send the telescope to home. So we're going to go here and I'm going to go start up and I'm going to put find home. And then when it finds home, it will appear on this planetarium right here, showing where it's pointing to, basically. So we're going to go to start up, find home, and away it goes. It's moving. See the red circle is where it was sitting, and it says it's finding home right there. Takes just a second. It's pointing north, which is this direction, and it's got to come all the way around and point southwest, right down here. There, that's where it's pointing. So I can go back up here and go look up, and so that's where it's setting. That's where it's pointing. Okay, so now it's found home. So now it knows where it's at, and it can find objects in the sky from there. All right, so with that said, I need to go to the camera and we're going to take a quick image just to check focus. So I'm going to do a 10-second image. I don't want to save it. I'm going to do 2 by 2. In other words, bend 2 by 2 is, so if I bend 1 by 1, every pixel is a pixel. If I bend 2 by 2, every 4 pixels is a pixel. So if you understand cameras, you would understand that. So we're going to take a quick photo and we'll see what pops up. See how the focus looks. It's counting down the picture right there. Okay. So then it pops up this fits viewer, and you can see that the stars are pretty tight. That's just a 10-second image. It's with the luminous filter, so there's a little bit of a light pollution in the center there that you see. But we're going to go ahead and focus it anyway. So we're gonna we're gonna go to right here where it says Focus Tools, and we're going to go to at Focus 3, and this is fully automated focusing. So I got to remember that I'm at 5692. That's my position of my filter wheel. In case something goes wrong, I can go back to right there manually. If something goes wrong, generally it'll go back to there, but sometimes it won't. And I can go back to there knowing that I've got a pretty good focus going on there. So we're going to take a sample photo. So you see over here, it's taking a picture. And it's only taking a 2-second image. There's the stars. And I'm going to tell it to auto set subframe. So it's going to pick what star it wants to, so it wants to focus on that star. And then we'll put focus now. And it's going to start taking images, and it's going to be adjusting the focuser out there on the telescope. You'll see it in the stars here. It'll get worse. It'll get blurry. Say it got blurry, real blurry right there. It's not super duper duper dark, so this might take a few seconds. 16 seconds. Let's don't do that. Let's abort that. So it should go back to its 5692 starting position, which it did. And it'll take a picture. Um, so we'll get to a better position of the sky to focus in. So, um, and then I need to check my guider and make sure it's fairly focused. It don't have to be perfect. The guider doesn't have to be super good. In fact, it likes guiding likes the stars to be just a touch out of focus so that they can find the centroid bright spot that it can guide on. All right. So here's the image from the color camera. Yeah, the sails are just a touch out of focus. That's the way it likes it. So we're going to leave those alone. All right. Now we'll leave these alone for the minute. So I need to go back here. I'm going to minimize that. And I need to find out what I want to finish working on. I've got these are in progress. So let's see what this is. IC410. I got blue, green, red. Let's do got HA, and I got okay. So let's go back for some more HA on IC410. Okay, so now we'll go. That's what we'll go after. I got to find the location of it first. So let's open this back up. We're going to go to find, and I'm going to type in IC410 and hit find, and it tells me it's right there. Right there is where IC410 is. So I'm going to put closed loop slew. Now when I close loop slew, the telescope's, this is the meridian line, and it's going to go all the way around, come over to here, and that's going to take two images. The first image is going to, remember it found home, so the first image is going to, it's going to pinpoint what it's pointing at, and it's going to know where the location of the object I want is, and it's going to adjust the telescope and then take a second image to confirm that it's centered it up, and you'll see all that take place. So let's go with closed loop slew, and there goes the telescope. It's over in the west right now, moving up toward northwest. It'll go past north, which is, this is the meridian line. It's going to come down here and it's going to set up on the objects. So I'm going to go back to, once it sets there, I'm going to go back to the camera tab here, and we can see that it's taking the first picture right there. And it's just taking a 10-second image. So that's, look at that airplane. So now it knows where that is. See that box that just appeared? It knows where it is. Now it's taking the second image because it knows where to shift the telescope to get that image I wanted centered up. And it will shift. Watch the stars here shift. So it shifted the telescope. So now the object I want should be centered in this picture right here. Okay. So now we're going to get over here to guiding, auto guider, and we're going to have to start auto guiding. So we're going to hit the abort. Wrong. We got to take a photo. It helped take a picture. So I got to pick a star. So okay, so now I'm going to pick one of these stars, and I do a calibration with the mount. And what that means is it's going to check for movement in the gears and things like that, and so it can compensate for those. So I'm going to pick that star right there, and I'm going to hit calibrate, and it's going to move each XY axis 150 arc seconds, or I don't know how many pixels that is. I just say OK and tell it to, and it's calibrating. It'll start moving this image you watch. It'll move the telescope. It's moving the telescope mount to check for the slack in the gears and things like that, so it can compensate for it while it's guiding. Works on the XY axis. So it tells me it got a good calibration. I hit OK, and then I gotta undo the subframe because that's a subframe because it zoomed up on the star so it could see it. And then I'm going to go back to take another photo, back out to full view, and then I'm going to pick one of these stars to guide on, and I'm going to just double click over it like that, and it picks that star, and then I'm going to hit auto guide. And then I'll hit graphs, and the graphs there it zooms up. It shows me. I can put the crosshairs on. You can see the RGB pixel value on a color camera right there. There's a red pixel, two green pixels, and a blue pixel. And you can see the stars moving just a tiny little bit. So we can go to graph right here, and I can pull up a guide graph, and we can get this kind of set. And this is my every green blob is a correction, is a mount correction. So remember in the previous videos I talked about it monitors the XY axis. Every time this star moves off of that XY axis, it compensates for that movement with a bump to the mount to pull it back. It's doing everything it can to keep the centroid of that star in that XY axis right there in the center. And that's what all these little bips are, is to keep that mount. It keeps pulling it back because it's trying to drift out a little bit. Now this is, bear in mind, at the pixel level at trillions of miles away. So these are extremely minor movements that you would never see with your eyes. And this is my scatter plot. This is showing the bumps at how far off it's drifting, which each one of these squares is a pixel on the camera. So my error is only 0.08 of a pixel. Very, very super tiny. All right, so that kind of explains all that. So now we're going to get set up and we're going to we're guiding good. We'll take a test image camera, and I'll put these over on the other screen so that we can see, you can see what I'm doing. I'll put that up there, put that up there. In fact, let's go ahead and do see if we can do a focus run here on this one now. So we've got camera, focus tools, at focus 3. We're 4x4. Let's go, yeah, that'll be good. Take a sample photo. This is a brand new camera that I'm using here. Um, this is only the second time I've used it. So let's auto set subframe. This camera cost about, oh, 15, 1600, 1300 new, and I got it on sale out of a place out of Denver. So let's go with autofocus, and hopefully it stays on that center star. It should, because it's the brightest star. So all right, so it's not wanting to focus, and the reason being is because my seeing tonight is terrible. Seeing affects guiding. So the seeing is atmospheric. If you go out in the evenings and you see like real, almost looks like cirrus up there in the sky and it's hazy and stuff, that's affecting seeing, the ability to see through the atmosphere. So we're just going to go with it. I think the stars are pretty close. They look pretty good. So We'll just go with it. We'll just go with it. All right, so we're going to go back to camera here. We're going to go to take series, and we're going to take series. I'm going to get rid of um, that. I'm going to take these. We're going to do 600 seconds, which is 10 minutes. We're going to go 2 by 2, and it's a light frame, and we're going to take HA, and we'll do 10 of them since I usually do 10 at a time when they're 10 minutes long. So if there's a problem, I don't get too wrapped up into it. I don't want any delays. This is for delays and for settling of the mount stuff, and I want to automatically save them. I want to auto save my IC 410 2600. I've got it to, it'll create a date-based folder for today automatically and put those folders in there. So I'm going to hit OK, and we're going to go with take series, and it's going to move the filter wheel to the hydrogen alpha filter in the filter case, which you can see right here. It said current filter is hydrogen alpha, and it started taking the image. Okay, so in 10 minutes, we'll see the first image come up in this block right here, and you can see the guiding is still holding really well. Looks really good. It's nice and flat. That's what you want to see. Not a bunch of wiggle wobble. And my scatter plot's pretty tight. I'm still under a tenth of a pixel. So this is there'll be what that means is I get a very clean image. It doesn't have to a bunch of blur and things like that into it. So it just makes a difference. So with that said, I will come back in about 9 minutes and we'll pull up the first image and you can see what it looks like. So I will be right back. All right, gang, so we're back. We're down to, we got just about a minute left on this 10-minute image. You can see the guiding still relatively flat, still holding at a point zero, now it's down to 0.08, so it's improving. Um, it'll bounce around a little bit with the seeing conditions outside, so nothing too critical until it gets up into where this is 5 or 6 in this area. That's a bunch. That's half a pixel, whatever. So um, right now, not too critical. So here in about 40 seconds, we're going to have our first image come in. And we'll see it here. And then I'll open up another program that I use to check the images as they come in. So this is collecting it. And I'll use one to pull it out of that folder, and it's a viewer where I can manipulate it a little bit with some sliders and kind of clean it up and see what the data kind of looks like before I go full process, which I'll do a video on processing once I complete all this stuff. So you can see how intense processing an image is. So, all right, 11 seconds left. We'll get our first image right here. This is IC 410. This is the Tadpole Nebula, and I'll show you that. It's called the Tadpole Nebula. So let's get this right here in the middle where you can see it. And here we go. There's our first image. So there's the two little tadpoles right there in this nebula. This is all hydrogen alpha gas. We cannot see this with our eyes. You look at this in a telescope, you don't see this. If you look at this area, all you're going to see is the stars. This is gases that we cannot see and take specialized filters to see them. So now that we've got our image in, it's already started another one. So we're going to go ahead and I'll open up this other program and show you a cleaned up version of the tadpoles. So we're going to open up this one right here. It's called Astro Toaster. We're kind of a cool name. I know the developer of this program. Um, so we're going to slide that right over there. And we're going to slide that right over there. So there you go. You can see that is, um, let me move this over here. That's all these HA images stacked together. Okay. So that's 25 times 10 minutes. That's 250 minutes. That's 4 hours, over 4 hours of data right there. That's all stacked together, and you can start to see um, detail in the gases and things like that. And the tadpole's nice and shiny. There's a tadpole that's faded away right there. Um, so that's and this is really unprocessed. They're stacked together. This program doesn't allow a bunch of data manipulation. I can just do some manipulation to make it and clean it up, and really just use this to monitor the data. If a bad one comes in, it streaks the stars or something like that, all I got to do is uncheck it, and then I know to delete that one. So that is what it all looks like as it's coming in over the course of the night when I imaged this last time. Um, so what I'll do is I will uncheck all these, uncheck all, and then when I say now it's going, when I do monitor, I want it to monitor my folder. I've got it set to there. It pulled that last image that I just took in. It just pulled it in right there. And I want it to stack these images, and I want to auto refresh, meaning once it's done stacking, it's waiting for the next one to drop in the folder. But by unchecking all these, it won't use these in the stack. It will only use what I get tonight over here. So you're going to see this image change. It says it's doing auto star threshold right now, which is the you got star counts, it scores the image. It's doing its own thing in the background to determine the quality of the picture, and then it will. Our little bar up here shows our progression. In fact, I want to stop that because I didn't do the right setup on this thing, and I want to go to picture scale 2.5 because that'll help it process faster. Now we can go with monitor stack and auto refresh. Um, by going half picture scale, it'll help it process faster. So there it did. When I get the green box here, it's processed that picture, and that's what one single image looks like right there. Okay, so that's that's what one looks like where you saw before. It was all a lot smoother with the. Now this is a bad. I mean, this is not a good processor for this image to really make it nice. That's done with this program right here called PixInsight, and I'll get into that in another video on processing this data and show you the intricacy of processing a deep sky image. So anyway, I just wanted to kind of give you an initial run through of what it takes to get set up and all the way through to right here is our first image. So that's everything that I do every night I run the telescope um, to get set up to image. Now, from now on, it's just fully automated. It does its own thing. It's going to take 10 pictures, or I can put 50, or I can put 100. I can put multiple filters. I can put red, green, and blue, and it'll just keep bouncing through them all and putting them in the folder. And I can go to bed if I want to and let it run all night. Okay, so there's a multitude of things that can happen. Once the initial setup's done, I just sit back and watch it work. So anyway, I just wanted to give you guys that little quick rundown on the first run so you kind of see what happens to start up the telescope and start imaging. So you see how long that took to get it fired up, connect everything. Can't get the focusing right. So there'll be a reason, and I imagine it's got to do with seeing. My seeing is terrible right now and it won't clear up till about 10 or 11 o'clock. So with that said, I hope you get some benefit out of this. I know a lot of my friends are interested in this telescope and how it works, so I thought I'd do a short series of videos and explain some things to you. And then at some point, we'll do a live session. So thanks for watching. Please like and subscribe if you would, and I will put out a few more videos of different processes of the telescope in the near future, and we'll get a live scheduled up here in the near future. So thank you for watching, and see you later.